Come on, Rumble. Rumble live, are we good? Showing me? Hold on. Make sure we're live on Twitch, YouTube, and Rumble. Am I good? Okay, cool. Get a little Rumble symbol up there, right over here. Welcome in, everyone. This is a live showing of ERC-20, how to code it, the understanding of it, and why you should know it in general. If you're into cryptocurrency or into cryptography or anything decentralized, you should definitely know why you are getting into the ERC-20, ERC-721 for NFTs. So the reason why you want to understand ERC-20s is basically because if you are buying a crypto, if you're buying something on Ethereum, you are generally getting a type of USDT, you're getting a wrap Bitcoin, you're getting a wrap Ether, you're getting whatever your friends told you or whoever you saw on YouTube, right? So the reason why you want to understand is because it has a certain standard. And the standard follows a lot of different precautions, security precautions you want to make sure that are aligned with Ethereum. So let me show you my screen over here. But in general, I've done cryptocurrency for a long time and different types of computer science ideals like websites, apps, different plugins, different stuff in general. And I have a few websites up, but generally I want to show my cryptocurrency websites because that is generally something more interesting for me. And let me show you my screen here. Give me a sec. All right, and then for this, I might just take off my face here. It's not super important. Let me see. All right, so in general, so this standard I'm talking about, this proposal is basically ERC-20, EIP-20. Is basically the token standard of what ERC-20 is. It was made around 2015, and it is the standard interface for tokens. So when you're getting a wrap Bitcoin or wrap ETH or whatever, you are getting ERC-20. And some of the methods and different events it causes goes on the blockchain. And the blockchain is basically an agreement, a ledger across the entire network it is made on, and you're basically okaying and ensuring something is going to happen. So for instance, approval. So let me go down the line of what some of the methods are. And then the abstract of it, the following standard allows for the implementation of a standard API for tokens within smart contracts. The standard provides basic functionality to transfer tokens as well as allow tokens to be approved so they can be sent by another on-chain third party. So the motivation is the standard interface allows any tokens on Ethereum to be reused by other applications from wallets to decentralized exchanges. So for instance, you can okay a router, you can okay a permit, which I'll do later on in a different stream. And I want to do more of a streaming type of ideal because it's just easier and faster, especially if I have a lot more content to bring along. So this permit, this router is like a decentralized exchange that you're okaying your tokens to be approved on, so they can use your tokens on your behalf. And then while you're approving your ERC-20, let's say USDC for another example, to go to another wallet or another address that's within your wallet, and then it receives your ERC-20. So the methods here are name, symbol, decimals, total supply, the balance of the transfer from, the approval, the allowance, and then the events or the transfer and the approval. So the methods, you can literally use the methods within Ethers.js, Web3, just to name a few of these JavaScript frameworks, or let's say JavaScript libraries, to basically use these methods based on this ERC-20 address and its interface. So the name, it basically returns the name of the token So you'll see USDC, you'll see DAI, you'll see tokens like XRP, stuff like that. And then also hint too, the optional, and it says the same thing for all these. Optional, this method can be used to improve usability, but interfaces and other contracts must not accept these values to be present. So don't really, I guess, like hope for these like name, symbol, and I think a few others, decimal, yeah, decimal, symbol, and name to be there. Just have that as an optional thing. Symbol returns the symbol of the token. So whatever the symbol could be, like the symbol for DAI is DAI, and then USDT and US. So USDT and USDC are basically, they're mimicking the dollar. So USDT is Tether, and USDC is the United States dollar coin, if I'm remembering, and they just mimic the dollar. So they go in with the inflation and deflation of the dollar. So then you have decimals. Then decimals returns the number of decimals the token uses. Let's say 8, and it means to divide the token amount by this amount. So it's all these zeros, which is 8 zeros, and then divided by that is, I give you 1 to get this user representation. The same thing with the optional. The total is returns the total token supply. So, and then I'll show you that in the code because I'm going to do a demonstration of the code. So the total token supply is basically how much of the token is in supply. Correct me if I'm wrong. It may be along with the circulation as well, but I'll go over that within another video, or you can let me know in the comments or in the chat. So here the transfer also sorry, the transfer value amount of tokens to address 2, and then must fire the transfer event. The function should throw if the message caller's account balance does not have enough tokens to spend. So there are errors going on along in the blockchain too, but that's usually returned on the client side. And then note the transfers of 0 must be treated as a normal transfer and fire the transfer event. So even if you're transferring nothing, it's still an event you're doing on the blockchain because you're committing something on the blockchain. Take a little drink. The transfer from is very much similar to transfer, but it is doing something on someone's behalf. So you're doing it from and to this person and of the value. So transfers the underscore value amount of the tokens from address from to address to, and must fire the transfer event, so on and so forth. So it is taking the method and is using a withdrawal workflow, and you are doing something from an address and taking it to another address by that value on their behalf. So the other person on the other side has to approve of this. So no one can just use transfer from randomly. So that's part of the security precautions I was talking about at the very beginning. So we'll move on to approve. Approve, this is what I was literally talking about. The approve is approving a spender and letting that spender withdraw this amount of tokens. So it's like their allowance. And then note, this is very important to prevent attack vectors like the one described here and discuss here. Clients should make sure to create user interfaces in such a way that they set the allowance first to 0 before sending it to another value for the same spender. Through the contract itself shouldn't enforce to allow backwards compatibility with contracts deployed before. So I've seen some applications doing that, like right after they approved, they then approve to a 0. So it's like a security precaution you want to take. The allowance is more of a read only. So you see how, I'll go over this within the code. I won't do the allowance function, but I'll explain it here. The allowance is a read only type of functionality. So you're not writing to the blockchain, you're reading from it. So hence the view. Public is just having it viewable to the outside world, but then the view is to look at something, is to read something, and then it just returns this type of amount. So the uint 256, there's a uint 8, a uint I think 16 or 32, but then there's a 128 and then a uint 256, and then those are the like, think of it of number values within JavaScript and Java. They are the number values within there. In the future streams, we'll go over and do more detailed on that. And then, yeah, this is just viewing the allowance of the spender, allow from the owner. So we'll draw from the owner. So then we get into the events. The events are also logged onto the blockchain, but they also are read across any other blockchain. So you have L1s and L2s I was discussing in another stream. These events can be viewed across different areas within the blockchain. So Ethereum is one big giant blockchain. It has all these layers. And every layer 2, the base, optimism, all that stuff. It's also part of why you can do cross-chain as well. So we'll get into that in a later stream. So these events only here is transfer and approval. Some other proposals have other events and other number of events. So this one only has 2. So transfer must trigger when tokens are transferred, including zero value transfers. A token contract which creates new tokens should trigger a transfer event with the from address set to 0x0 when tokens are created. So this is the signatures, and these are all just signatures if you didn't catch it already. And then the last one, the approval must trigger on a successful call to approve. So whenever you're approving, this approval event happens. So you want to make sure all this is inside of your token, because it wouldn't really be an ERC-20 token if it doesn't follow the full approval. So in the rest of it, the implementation, there are already plenty of ERC-20 compliant tokens, as I discussed, deployed on the Ethereum network. Different implementations have been written by various teams that have different trade-offs, from gas savings to improve security. So those are some of the causes right there. Example implementations are available at OpenZeppelin, which is a good source of code to go over. So they follow it really well, and we'll just go over some of the methods and the events in this coding and the consensus implementation. The history, the historical links related to the standard, you guys can go over that, and then the copyright and the citations. All right, so you guys can go over all that stuff. You know, always do your research, always read on and read on. Let me put my sexy face back here. Oh, wait, hold on. All right, so basically we are going to go over a good code piece step by step. So that's like the whole breakdown. We'll go step by step on how to code this. So we will first bring along, First bring along a terminal. So if you guys are new to coding, I have a few coding videos, but generally, if you guys want me to break down any type of coding of anything, let me know in the comments, in the chat, because the more influence, the better. I'll just go step by step on how to do each and everything by the description and or title. So first, you want to make your own folder, which I'm in my own folder. It's like Ubuntu Linux-based type of command. So you want to open up a terminal and go to that folder. You can create it by mkdir. I'm already in there, so I'm just doing ls. I'm already in this folder, my demonstrations folder, and it's how to code a ERC-20 token. So now we're going to do an npm init. And then these are the times you're going to wait a little bit and have the computer do its rendering and all that stuff. It's just how your computer speed is going to be. So it's nothing to do with network. You know, it's different realms in computer science. So we're going to make this package name, sure. Version. So these are all little things you want to interact with. You don't really have to change anything. Keywords. Everything looks good. All right, so I should be able to do, and then this flag I'm doing, the -A, is to see everything within your system of the LS. So it's not just the files and folders, it's to see the hidden files and folders as well. So if I do this, I have a package .json, right? And then we can open this up. It's not gonna be much because you just saw it. And I'm using Visual Studio Code. Visual Studio Code is what I'm used to. You can use a few others that don't come to mind because I don't use them. All right, demonstrations. All right, so then once you have made this, you officially have a Node.js project technically. I always trust it. That doesn't pop out too much. You always have a Node.js project anytime you have a package.json and you have npm. Like the one thing I didn't show, npm-v to check your version and make sure you guys have npm installed and Node.js installed. Once you have this installed, we should be able to do and then also I'll do it like this. So npm, I remember it, but we can always do the documentation. -s save -dev hardhat, right? So npm install. We want to do an npm install. You know, npm install hardhat, and then we can load up the documentation right here. Okay, so npm install, right? So once you go through npm install, you'll go through all this stuff. I just want to show you guys myself since I've done this multiple times and you guys like that handheld idea like everyone else kind of does in general. So -save, so I'll explain what -save is. -save.dev is saving to the dev dependencies, and -save is just saving to your dependencies. So we're intentionally having to save to our dev dependencies, and we'll let this install as it comes through. And let me check the chat for the first time. If you guys have any questions, let me know. My computer's running crazy. I had a addressing my community video, and I was talking about this too. So yeah. Okay, so we have hardhat. What else? Let me skim through just to remind myself. Let me see. Yeah, we want to do it in it, right? npm init. So once we do npm init, we basically have everything we need to start coding in Solidity, to say. Not word by word, but yeah. So we should have, so now we have, since we have hardhat, we should be able to do npx hardhat init. All right. So once you have this, you have different options to choose from. And you guys can use Waffle. I haven't used Waffle in a while. There's hardhat, and then there's a few others. There's Vim. There is, I think, Gancha, but I think that's deprecated completely. And deprecation is basically something that is not supported at all. While the one in between, I'm trying to think of the word, but then the stable is the new, the one in between is like still there, but then I maintain it, deprecated, it's ended. So, but through here, through these options, you guys can pick generally just JavaScript projects. You guys can do an empty hardhat.config too. I don't code much in TypeScript, but I will eventually do some TypeScript videos. It depends. So you guys can do a JavaScript program just to start out with. You can name your root this. Generally, so if you are going to push this to a GitHub, your git ignore is basically taking away anything that's really sensitive, and it should come in preloaded with some of the commands that you need. So yeah, make that. So do you want to install project dependencies? generally, yeah, you want to just be up to date with everything. You want to just be up to date with everything. So, I hope you guys in the live chat and the past broadcast enjoying this full breakdown, step by step, exactly what to do after this and that, all live too. Done so many tutorials, all edited. Now I just want to do them live. A little bit more fun too. I can interact with you guys too. Have to wait for that. May take a little bit longer because my computer has to run more and, you know, streaming and using a lot. I am using a MSI Afterburner, so I might just put that on and put on the fans. Let's see what happened. All right, so we should be all good. So some things to note: if you see vulnerabilities, unless they're critical, don't really worry about them at all. But if you still worry about them, use npm audit right here, and then you'll be able to see what is going on and potentially fix the problem if it's really bothering you or your system in general. But now, so it is fully downloaded, and it gives you this environment, right? So we started out with nothing, and now we have this project right here that we can do whatever we want. The README is just, you know, like whatever you want to do with hard hat. The package.json, the package.lock.json is basically all the extra dependencies and dev dependencies that it needs. And then this is really important. The hardhat.config.js is really your settings for hardhat. So read the documentation to know more about those settings. And then the get a nor is basically, yeah, like you don't want to push node modules, will take way longer to push it to GitHub or any server you want to push it to. .env, you don't want to push it .env at all. You want to make sure that is in memory on your system, you know, the other files. So once you do this step by step with me, lock.json is a file where it's a testing file, really. It's nothing too special with it. And then it's just looking at the lock contract that we're going to go over. A contract in general, not going over the lock contract. And it's just testing the functionality of it. So in this video, we won't be testing any functionality. I'll just be showing you how to make this contract. And then if you guys are in the comments and liking it, we'll do deeper analysis on the coding. That's good. And then ignition, I haven't really touched much on ignition. So here's a little thing right here, the little contract. We'll make something way better than this. All right. So step by step, we're going over each and everything, and it's not too much. I'll be calling it live with you guys, but it's nothing too crazy. Don't overthink. And some things in Solidity I'll go over as well. Let me go ahead and make this. So when you follow along with this, you can call it anything you want. Just make sure it's the same name from when you want to test it. Because if you're going to test it yourself, you want the same name for your, let me see this, your get contract factory, if I remember. Get contract factory. So you want to have that as the same name. So just remember that as the same name. So we'll just call it token. And it has to have the .sol at the end. I'm going to code it step by step. Sorry if I hit the mic. All right, so generally first you want to have your pragma. This is needed in general in Solidity. So you want to do pragma, Solidity, and then the version. I usually do 0.8.18. It's the it's not like this most stable version, but it's the best version to start with. And then the caret that you see right next to the 8 is basically looking for more features that don't change what 0.8.18 is. So anything to improve what you're using, if I'm saying that right, but let me know in the comments. So that's the next thing. And then you can think of it as a license, a identifier for your Solidity contract that you're going to put up on the blockchain. So you can put up on Ethereum, on Base, Optimism, Avalanche, Polygon, anything that's a L1, L2 of Ethereum. Because Ethereum is a L1, is a L2. I explained it already in that past video. You guys can check it out. I'll attach it somewhere in this. So there's also, since we're using hard hat, there's also one thing too you can do. It's a console. It's a hard hat console. Let me see. All right, so you can use hard hat's console log. You can't do console log straight within Solidity, but hard hat has the built-in console log that he did. We can check it out possibly. We can check it out later. It's not log, it's sol. We can check it out later though. If it doesn't bring me to it quick. Okay, it does. Okay, cool. Live. We do this live. Okay. So they basically made console log within here. And it is a Solidity contract. And it has all of these logs, right? It's communicating to, let's say, some payload, right? They named it _send log payload right here. They are taking whatever you put in. So let's say for this one, it is a byte and P0. So yeah, let me use this one. So I usually use it for strings, and whatever I get back, say within an event or within the required that we'll go over, or anything in the fallback or the receive that we'll go over possibly in this or another video, you know. So if I'm going fast, we'll eventually go over it within another video, another past broadcast. So you can input a number, you can input a string, a boolean, all that good stuff to now see what is going on within your Solidity contract. So they made that for Solidity for you to debug basically. So that's just a quick overview of it. So you can use that if you want to. So first thing that you're making, first thing you need to do within a contract of Solidity is to do contract, right? So contract is like a signature for what you want to make within a Solidity contract. So try not to use the same words. So you can name it token. The name you're going by is the name of the contract. So to be more clear on that, so the get contract factory is what is referring to the name of the contract. So not the name of the file, technically, the name of the contract. Name of the contract would be that. And we're going to speed up a little bit since it may take long if I'm going at this pace. So we're going to do a string, and we want to do a string any set of numbers, and then we're in global. This is a global scope, a global view of what you're going to put into each and every method that we saw in each and every event that we saw. That's why we went over this stuff. So it's not too like what's going on. So, and then usually you want to make them public and then say this is the name. You want to do a string and then say this is public, and then it is the symbol. Then you have the decimals, then you have the total supply. So let me go ahead and make those. I won't be doing any comments like this. You guys can do comments. I won't be doing any of that. So I don't want this to drown on any longer than it is. If you guys need to slow it down, just slow it down or just pause. So if you see me looking back and forth, I'm obviously referring to notes since you don't want me to remember from memory, which I could, but so here is what I was talking about. So I don't remember all of them. I'm not a robot, but a uint 104, all that good stuff. They are different storages that you would use for a integer. So I was using the wrong thing. It's not a number. So I was referring to numbers in Java and JavaScript. They have numbers. If I remember, those are non-primitives. These are your integers. If I'm saying it right, these are your primitives. So you only use primitives within Solidity, but you know this is off the dome right here. So for total supply, you usually want to use the longest or biggest one to say, better word. And you want to do public and then total supply, right? So, and then now we want to do, let's do a comment. Let's do tracking balances, because this is something it's a little more advanced. So tracking the balances, anything you want to track and keep awareness of within a contract is able to hold different storages. When you're able to hold different storages, you can put that within a string, a uint that we have, or even a boolean. Now, to hold many, you would need a mapping. So I'm making a mapping here, and this mapping is basically what you're pointing to the storage and what it's going to give. So you always want to do address pointing to with the equals and the less than or greater sign. And now you want to do, like, since this is the balance of, we're doing the uint 256, and then we're doing a public and a balance of, doing another mapping, a trick within VS Code. I'm not sure if it's in any other text editor. You can do Alt Shift and down or up. It doesn't matter. You are cloning this line to another line. And then actually now, a little more advanced, you're doing a mapping instead of a mapping. So think of hash tables, think of hash maps. You have keys and values, and you are mapping another key value inside of there. So it's like a big structure, a big tree within there. You have mapping, and then this mapping is a mapping of addresses. Oh, if I remember correctly. This mapping will pull to another mapping. This mapping is nested in this mapping, so don't think about it wrong. This mapping here is nested in this mapping. This is its own mapping. You know, it's not like lambdas in Java and JavaScript, or just Java, to my memory. This address is pointing to this mapping for its address of a allowance. So it's not gonna be a balance of, it's of a allowance. So let's do an allowance. And I'm pointing to those things, right? I'm pointing to uint 256. Right? So let's go ahead. Let's now do the events. Let's do the only two events, the transfer and the approval. And then the event transfer is basically, it has three parameters inside of it. The address. So I'm gonna call this index. I don't fully remember word by word the meaning of index, but basically index would be something for a particular part or a particular area within an event. So, but word by word, as you see, I do not remember. So, but there will be future streams. You guys are supporting. Address and then a uint. So so when I code, sometimes I like to go over at let's say a broader view, a less technical side of what I just created. So we created this structure within this block scope, right? These two curly braces are this block scope. We created a naming of this event. So this event is named transfer, and then its address index to from, index to, and then a value. So I like to just take a step back and then look at what we're making. So I actually did this wrong. Hold on. It's actually a parentheses, so it's all the same meaning. It matters what symbols you're using. It's all the same meaning. This just a little faster, because we could do another stream later within this day. So I'm aiming to stream multiple times. depends on the support, right? So same idea, same meaning, no different. This is just now the owner, the spender, and the value. Value, right? So those are the only two events that we are creating. Now, this is usually the structure you want to take in general in making a Solidity contract. Let me take a look at the chat possibly. All right. And you want to have your this is object-oriented programming, right? So you want to have your globals, you want to have any of your just had it the access modifiers, right? It's not technically an access modifier here, but think of it as an access modifier. And then, the events, the approvals, whatever else you need that's going to be used within the methods. If you're doing your polymorphism or some abstraction within your contract here. So now we have that squared away. We want to, in object-oriented programming, make our constructor. So our constructor could be of anything. In this case, it's a lot of things, right? So we want to just take in this creation, right? This is where we construct. This is where we create. We're making the name. We're making the symbol. I think the decimals as well. It's going to get long, so I'm probably going to make it vertical. String and a symbol. So one practice you're using within object-oriented programming is if you're using the same meaning, like you want to point to the same memory. Let's go to object-oriented programming. If you're using the same variable, you want to do a underscore because you don't want to have a naming convention. You don't have a naming problem. And you also want to do memory as well. You want to do memory, and then you want to do underscore symbol. All right. So no need for memory for your integers, right? So not too many. It's just the name, the symbol, and the total supply. So now we're just going to use name. We're going to do underscore name, and then the symbol that we have. It's not popping up in your IntelliSense. Like people call it IntelliSense with like this stuff pops up. It's not popping up. There's like different plugins you can do. I don't really care because I'm OG. And OGs know exactly what they're doing. They don't need little images on the screen to remind them, oh, you're using this. It pops up in general. It's in VS Code, but you can turn it off if you want. Actually makes you better if you're using your memory and not depending on so many GUIs, because all this is GUI, So now we have our name aligned with what the constructor is going to be. We want to make sure that this token is sizable, right? So our total supply now is attached to what it is equal to when it's first created. And the constructor only activates when it's first created. So we're going to do, so I can type, underscore, right? So I'm going to start doing this. Some mistakes here. Some mistakes. Uh-oh. Start copying and pasting a little bit. As long as you're understanding within the live stream and the past broadcast. You want to now take the total supply that's coming in and multiply by the amount of decimals that are in, right? So we want to do a double asterisk. Do a double asterisk, and the double asterisk is using the exponent of this mathematical function. So the decimals, so 10 to the decimals. The decimals is the number being expedited on. So balance. Now we're going to the balance. We made balance up here. We're using a mapping. So the way you want to use a mapping is the name of it, and think of it, the mapping, as the hash table, and we have the square brackets. So if you have done coding before in Java, JavaScript, and I'm pretty sure in C++ too, you have these square brackets, and then now you can look at the indices, the indexes of this mapping, this hash map, right? So this mapping to say something that is global within Solidity is the message. The message has, just real quick, the message has data. The data is basically the information coming in from a transaction, any kind of value, any kind of bytecode. That's the message data. The gas is the value of that data, and the sender is the one sending the data with the gas. And the signature, from memory, I haven't used it much, so I'm not too sure on the signature, but the sig, I'm just calling it signature, but the sig is probably the signature, and the value is of the value of the whole transaction. So I'm going to use sender. When we use sender, we have the total supply, right? And then remember, this is only being used within the creation of the entire functionality. So speed up just a little bit. So now we're going to make the functions, right? We're going to make the methods to say, right? The same thing. So we're going to call a function transfer function underscore transfer. And when you see the same exact type of methodology, it is using either polymorphism, abstraction, inheritance, and what was the other one? Encapsulation. Using polymorphism, if I remember, right? So let's do function transfer, and then this function transfer takes in two of the function signature, if you remember what transfer is, and it takes in the address and the uint value. So address and the uint value, right? We'll underscore it just to follow the same exact procedure. This is, and then also, since you're not going to see allowance that I mentioned from before, it still follows the ERC-20 mechanism. It still follows the proposal. It just needs to have these minimums that I'm showing right now. So let's go ahead. I'm making a public. So I'm gonna follow an old way. So I'm gonna follow a old way of doing this. So let me undo this. Actually, no, wait. I'm misreading what I'm doing. Hold on. Misreading what I'm doing. Within any type of signature, you need a public, and a public is usually something that you can see that I explained already. And then this also returns, if I'm remembering from it. And then now, following my documentation, you can now do a require, is what I meant to do inside. Okay, so require is a check. It's basically checking this type of variable or variables to be succeeded. If it's not succeeded, we can do a comma and then y gonna succeed. So in this case, I won't do a comma. I'll do the underscore 2 that we have up here, and if it's equal to the address 0. The address 0 is the, if I remember it correctly, is the address of the person making the call. It's not the person that is of the contract, but you guys can always let me know side of the comments. And we'll also do a mapping. So balancer, back over here is our mapping. Getting pretty far here. We'll do our underscore. Actually, no, I'm looking at the wrong one. We'll do, sorry. So we'll do this part out somewhere else. Don't get too jumbled up. I meant to do this is for our internal, so our underscore transfer. I was looking at the wrong one. We want to do a balance, balancer, a mapping of. So that's why I got mixed up, because we were supposed to do this first. So we're checking the balance of, and if this user has a balance of more than a value of this value actually, then it can't be done, because you have more of something that you're trying to transfer, you can't transfer. It doesn't make any sense. So can't do that, buddy. But yeah, you guys can fact check me on this address 0. Bro, how this address 0, we actually use the underscore transfer. So this underscore transfer now here, so we're using this underscore transfer, we do the messenger, all right, the sender, then we do to that person, then the underscore value. And then once that's all done within that function that we're about to create, we'll do a return true. All right, so let me go ahead and take this. I think it's better if I code it all the way through. That's why step by step. I don't want to take from what I'm reading. And if it's the same exact thing, then we can add on to it. So I'm gonna go a little bit faster, so don't be too scared. This becomes the from, right? So now we have a from, too many commas there. We have a from, a to, and a value. This is very similar to the transfer from, but we're using that signature to use within our transfer. So this is where they said there's different implications. You know, there's different implementations of this ERC-20, of this proposal. So that's why we're not putting in the allowance, or we're doing the transfer from itself. We are doing a spicy version, to say, of this. Now we have this. Want to follow good coding practices and keep everything indented and all that stuff. As long as you can read, you know what I mean? Like, I know it's like good practice, but you know, it's good practice for beginners. If you basically can't read this, that's a problem. You know, like, you have to read it all the way through. You gotta look left to right. This is a whole function signature, and once you go under, this is inside of that function. That's what that means. So, if you guys ever wanted a basic tutorial on coding, let me know in the comments and in the chat as well. One thing missing is one thing wrong, actually. Since this is our helper function, polymorphism, if I'm using the right, principle of object-oriented programming, this will be our internal. And internal is something that can be used outside. And there's differences between internal, external, and public. I can go over that in another video. And generally, this will not return for now. So, a voice cracking. Make sure you have all your semicolons as well. Semicolons aren't needed in here, so I made a mistake as well. So you don't need semicolons within a signature, a global access modifier signature. But let's use the name of it of an event. You'll need a comma only after semicolon. Only after you need a semicolon. Right? Everything good? Everything good, everything good. All right, let's go. Let's keep going. There's nothing else to explain. I'm explaining every single little part that you may have a question on. And if I didn't explain something too clear, let me know in the comments as well. So let's keep going. So now, since we have this from, that's why I was referring to it. I was like, we don't have from. We now can refer to from, right? From is us. From is the sender. And from is equal to the balance, right? So the balance of from underscore from minus. So The reason why we're doing this, it's going to be minus underscore value. The reason why is we want to subtract from the value from this person to now have the balance, right? So we're taking the balance. We're looking at from us, the sender, right? So let me use this. From is us, the sender. Taking this, we're doing minus. This is a minus, and then this is the value. Minusing the value that we inputted. So rewind it if you did not understand that. That's pretty basic. Let's do a copy of this since, you know, taught y'all that 2 minutes ago or 10 minutes ago. That's what I'm trying to blaze through this a little bit faster now. Now we're looking at the 2. The 2 is whoever we put in. Whoever we put in is the 2. You know, we're sending it to that person, whoever, right? Plus the value. Then lastly, since we want to follow this protocol, this proposal to say better, as we went over it, we want to emit a event. Emitting an event is letting this know that something has happened. You want to know what's going on within your program. That's why we want to do this event. That away. All right. So cool. So now next, and the good little practices and all that stuff. So we're getting pretty far. We're getting there. I was out there for a reason. All right. Getting pretty far. Now we have the transfer. We have the helper of the transfer. We're now going to do the approval. All right. So the approval is actually going to have one methodology, one functionality. So I'm going to approve. Same thing. Just a signature. It's just a signature. So I don't have to slow down and explain that again. 1, 2, 5, 6. We want to do the spending and the value. Here. Right. You also want to make sure this is public for this token owner to use, or anyone can use really, because it's public and it's not only the owner. We'll go into that later. There's modifiers. So I was talking about access modifiers as general and object-oriented programming. It's modifiers as well. We can always go over that later. You guys are active in the chat, right? So this line, we'll do a spender. And a address of 0. I was saying that this is the address of 0. It's not the user of this token, but can let me know. We now, since we have done a double mapping inside of this allowance, we now have to do 2. So that's why I was referring to hash table. Is now you have a double mapping. You have to refer to it inside like this, unless you want to refer of all of what it has. So the messenger, not only of what it all has, but what it specifically has, would be of this spender. All right. So we're gonna take a quick break. I need to use the bathroom. I'll be right back. So it'll be like 2 minutes. Do this. I'll be right back. All right, I'm back. Didn't want to take too long. Okay. Guys are detail oriented. I was getting a little antsy. Questions? Any questions? All right. So let me know in the chat and the press broadcast. So any questions, let me know. We're going to continue. I don't see any questions. Making sure you're looking at that specific spender. You want to equal this approval of this amount. All right. Once this happens, I got a smoothie, so got seeds. Once this happens, we want to do our approval. You're emitting an approval. You're emitting an event, right? So which is from what we did. It is of this. So usually now when you're coding, you may not have something on the side, something to go by, something you already coded. You're not sure of what you made, just go back to what you made and look at it. We have the owner, the spender, and the value. So spender, give me the italicens, sender. Oh, sender, yeah. Okay, sender is the spender. That threw me off right there. Threw me off. Okay, and then it will be, it will then be the spender. Same old thing. And then the value that we have over here. So we're emitting this event, right? So once we emit this event, we want to now return true. And I'll possibly put a little timestamp of where you can, I guess, skip. Like I went to the bathroom and all that stuff. Wasn't trying to, but I really had to go. The last one, couldn't hold it to the last. The last one is a transfer from. Transfer from, right? So transfer from works a little bit differently, but then we're going to use this underscore transfer and be able to reuse code. So this is why we want to use polymorphism, because we don't want to be redundant within object-oriented programming or in programming in general. So our signature fully is what we have gone over. Our signature is the from, the to, and the value. Same old thing. Same thing. That here, right? The from, this, the to, and then you went. Usually, you just want to be safe and go by 256. The value, right? Want to return. I want to go ahead and end this out a little bit faster. Full success. Since no one has questions. I'll slow down, people have questions. But live, we do not have the questions. So in the comments, let me know of any questions. So let's do our checks. Let's do a require. We want to require the value less than or equal to the balance of our mapping from this person. So that's how you talk in computer science. You literally say what you're doing and you code out in a different language. So I'm saying one language and I'm typing another. I'm typing one language and saying another. Boom. Hey, this is pseudocode. Da 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 da. I mean, same old thing, you know. Semicolon. You now want to copy that down with the Alt Shift down up whatever. I want to use down because we're going down. We now want to use the allowance, which is our double mapping. Once we have this allowance, we have to do our double mapping, like I said, and we are doing the message sender, right? I'm doing the message sender. So we're nearly done. So, and then people want to do different spaces between. I've changed it up a little bit. I've done no spaces here. I code for a reason. You guys watch and see each and every part that I do it for a reason. So one function I just did, the approval, no spaces. Transfer has 2 spaces in between each and every line. So it's pretty much based on your preferred way of coding and all that stuff. Some people want you to do spaces if you're part of a team. You know, you gotta be used to both. It's the whole consensus of that. You gotta be used to both. You gotta be able to read. Gotta be able to read code. No spaces or not. All right. So let's go ahead and reference allowance again. Once you reference allowance, we want to do a resetting. Right. So resetting is of this person. So from, and you want to do a message dot sender. So you, this is going to equal the allowance again. Right. Any questions, let me know. Underscore from, and then I sender minus the value. So a little redundant. You could in that moment just copy that to a variable, and let me say it like this, because then that variable has to equal what that last value is. So whatever sender is going to be a, if I'm saying it right, yeah. No. So yeah. So it's gonna be of uint, referring to the sender for this uint, it's allowance. So you can put that in its own variable like this, and then the name of it, the allowance of sender. You could put your little underscores, it don't matter, and then this whole thing right here. So up to you. But for now, I'm not gonna do that. So do this line again, minus the value that is being transferred from. So we're going to reset that allowance. And now we want to now use what we did from before, which is this function. We have this function that we made, the underscore transfer. We're going to use that inside of the transfer from. So, and this is the last piece. Let me know in the comments if this is the most transferable. I said transferable. This is the most thorough presentation of and we are done. Boom. Let me know if you guys understand this. If you guys have any questions, it's most comprehensible. Yeah, I try not to use too many big words. I try to be as slow as possible, speed up as, efficient as can be in this. But this whole thing can be an ERC-20 token, right? You can take this and put your own ERC-20, and then boom. In another stream, another video will show how to mass produce tokens. You're just simply using the constructor from this token. So whatever this contract name is, this is token. You're now using the name, the symbol, and the total, and then you're just mass producing this token. So it's not the production weight that I would confirm on, but a lot of people have done that to mass produce a token. A lot of people got their tokens through, these type of scenarios. But if this is the most basic to advanced type of presentation, let me know in the comments. From this is the whole contract you want to make, or then another contract. You can call this one your token. You can make an exchange that takes in token. You can make a yield farm that takes in a token and an exchange, all that good stuff, right? So I don't know who else is going to break this down as much as I did, but I just broke it down completely. Each and everything, each and every line, that variable, that argument, that parameter, what this does, that structure, this data, that means that. So if you guys understood everything, let me know in the comments. Let me know in the past broadcasts, chat, and all that stuff. If you guys have any more questions, let me know in the Discord as well. All the links are down in the description. As the famous saying by many of your content creators is a go-to. I mean, come on now. We live, baby. So I'm planning on another stream, possibly a crypto stream. I need to do some more coding in my project. That's personal to CYBE, because this is all for CYBE, CyberConnect. And It's more of like a, not personal, but like underground type of project. So I'm doing that, and I'm planning on doing another stream later today. But the more support, the better. I can do more streams. But if not, the streams will dwindle down. So if you guys have any more questions, let me know in the chat, in the comments, and I answer all the comments literally like throughout my whole career, 10 years, 5 months, 6 months. I've been answering every single one. I went back in the past answering every single one, so you would not be missed. So let me know if you guys have anything you need, and I will end this right here. Anything you want to add before I end? Got a minute. We're live on Rumble, on YouTube, on Twitch. So let me go ahead and end. I'll see you guys later. Not too sure what that next stream going to be for cryptocurrency, but I'll definitely have another stream later in the day, around like 7, 8 for the gaming portion. I do a lot of gaming, PlayStation, and then there's crypto games as well that are on PlayStation, PC, and Xbox. So we'll find out at that time. So thanks for watching. Take care and peace out. And make sure you guys follow, subscribe, and share.